Hi everyone, today we are going to go over our study guide for our probability quiz. In exercise 1 and 2, refer to a bag containing 7 tiles lettered A, L, G, E, B, R, A. Number 1, you choose a tile at random. What's the probability that you choose an L or a vowel? So our key word here is or. And for our OR equations, we have two. So it depends on, does our two events, do they overlap? Can they happen at the same time? So our two events are L and choosing a vowel. Well, a vowel is a letter A, E, I, O, or U. And so L is not a vowel, meaning that there cannot be an overlap. These two events cannot happen at the same time. So we would use the equation probability of A or B is equal to the probability of A plus the probability of B. So event A is going to be choosing an L. So what's the probability of choosing an L? Well, there's only one L out of a total of 1, 2, 3, 4, 5, 6, 7 letters. So 1 out of 7. Plus the probability of choosing a vowel. Well, A is a vowel. E is a vowel, and A is a vowel. So there are 3 of them. So 3 out of 7. We just add those up, and we get that our probability is 4 out of 7. Number 2, you choose a tile at random, replace it, and then choose a second tile at random. What's the probability that you choose a B or then a constant? So for this, our keyword is we replace it. So because we choose a tile, look at it, put it back into our bag and choose another tile, that means that these two events are independent events. So our equation for independent events is the probability of A and B is equal to the probability of A times the probability of event B. So for event A is to choose the letter B. So there's only one B, so 1 out of 7 times the probability of choosing a constant. A constant is everything that's not a vowel. And so we said we had 3 vowels, A, E, and A again. So our constants is everything else. So we have L, G, B, R, and that's 4 out of 7. And when we multiply this in our calculator, we get 4 out of 49. Number 3, events A and B are mutually exclusive. We want to find the probability of A or B. Mutually exclusive just means that there's no intersection. All right, there's no probability of A and B occurring at the same time. So the equation we're going to use here is that the probability of A or B is equal to the probability of A plus the probability of B. So looking at part A here, all we want to do is add up these two probabilities, and we end up getting 0.75. And for part B, same thing. I just want to add up these two probabilities, and that gives me 0.7. Number 4, find the indicated probability. So if we look at A, we have the probability of event A, the probability of event B, the probability of event A or B, and we need to find the probability of event A and B. So we're going to use our OR equation, which is just the probability of A plus the probability of B minus the probability of A and B. So next step is I'm going to plug in all of these probabilities into my equation. And when I do so, I get 0.7 is equal to 0.25 plus 0.6 minus the probability of A and B. So this is what I'm trying to solve for. So let's combine like terms. So combine these together. I get that 0.7 is equal to 0.85 minus the probability of A and B. So I know that this here, whenever I find out what the probability of A and B is, this here has to equal 0.8. So right now I have 0.85 minus what is going to give me 0.7. Well, if you can't figure that out right away, what we could do is subtract the 0.85 from each side. And when you do so, we get negative 0.15 is equal to negative probability of A and B. But I don't want the negative probability, I want the positive probability, which means I need to divide each side by -1, and that gives me that 0.15 is equal to the probability of A and B. And that's my final answer. Part B, we know that the probability of event A is 0.55. We need to find a complement. So what is the probability of A bar? Well, to find this, I'm just going to take 1 minus the probability of event A. So I'm running out of room, but 1 minus 0.55 will then give me 0.45. Question number 5, events A and B are independent. So find the indicated probability. Our equation for independent events is the probability of A and B is equal to the probability of A times the probability of B. So all I need to do is multiply these two together. So 0.3 times this by 0.5, and we end up getting 0.15 is our probability. Number 6, events A and B are dependent, so find the indicated probability. Our equation for dependent events is that the probability of A and B is equal to the probability of A times the probability of event B, knowing that A has already occurred. Now, we have everything we need here, right? So once again, we're just going to multiply both these together. So 0.4 times 0.6. And when we plug this in our calculator, we get 0.24. And that's our answer. Now we're going to get into some word problems. So number 7, you roll a number cube. What's the probability that you will roll an even number or a number greater than 3? So before I even start solving this, I need to use my OR equation. So there's 2 equations for OR. So what I need to look at is there an intersection between these 2 events? Can they both happen at the same time? Can you roll a number that is an even number? And can that even number be greater than 3? And yes, that can occur. So I need to use my equation. Probability of A or B is equal to the probability of event A plus the probability of event B minus the probability of event A and B. All right, so event A is rolling an even number. So what's the probability of rolling an even number? It would be 1/2 or 3 out of 6. Okay. For event B, what's the probability of choosing a number that is greater than 3? So the numbers that are greater than 3 are 4, 5, and 6. So once again, that is 3 out of 6 minus which numbers, 4, 5, or 6, are even numbers. Well, that would be 4 and 6, so there are 2 out of 6. So now I just need to plug this into my calculator, and when you do so, you get 4 out of 6, which if you simplify that, and you don't need to, but it is 2/3. Number 8, you flip a coin and roll a number cube. What is the probability that the coin shows tails and the number cube shows a 5 or 6? Now for this problem here, it's probably easier to draw a tree diagram. So first, we flip a coin. Our 2 outcomes for flipping a coin would be tails or heads. After we flip a coin, we're going to roll a number cube. So there are 6 outcomes for each number cube. So for the number cube, it's 1 through 6. So what's the probability that the coin shows tails and the number cube shows a 5 or a 6? Well, here's tails right here, and 5 and 6. So there are a total of 12 outcomes, but for our situation, there's only 2 that we're focusing on. So our probability is 2 out of 12, or we could say 1/6. Number 9, we want to find the probability of A bar, or the complement of event A. So our equation for A bar is 1 minus the probability of event A. So for part A here, we know that the probability of event A is 0, so 1 minus 0, and that's just equal to 1. For part B, I'm going to do 1 minus 0.46, and that gives me 0.54. Event A for part C is 3/8, so 1 minus 3/8, that would give me 5/8 for my complement. And finally, for part D, probability of event A is 0.93, so 1 minus 0.93 is equal to 0.07. Number 10, cards are randomly drawn from a standard deck of 52 cards. Find the probability of drawing 3 hearts in a row if the drawings are done without replacement. So without replacement, that's our hint that we have dependent events. Our next choice of a card depends on what we chose first, since we're not putting that card back into the deck. All right, so for our first choice, we choose a card, and it is a heart. So we need to think about how many hearts are in a deck. Well, we know that there are 13 out of 52 hearts. All right, and we're going to use multiplication because these are dependent events. All right, so I grabbed a heart, I threw it out. So how many cards do I have left if I got rid of one of my cards? Well, that means I have 51 cards left in my deck. And I also know that my first card was a heart. So if I took away one of my 13 hearts, that means I'm left with 12 hearts. So that was my probability for choosing a second heart. So now with my third one, I got to do the same thing. So I chose a heart, I got rid of it, so that means that my numerator is going to go down by 1 because I have 1 less heart, and my total number of cards are going to go down because I just got rid of a card. And so when you put this in your calculator, you would get 11 over 850, and so you can keep it as a fraction, but you would see that the decimal is 0.0129, which is approximately 1.3%. So not a good chance that you would choose 3 hearts in a row. Question 11, cards are randomly drawn from a standard deck of 52 cards. Find the probability of drawing an ace and then a black card if the first card is replaced before drawing the second card. So there's a lot going on here. So first we see that it is replaced. So since we do put the card back into the deck, we now have independent events. So our equation for independent events is the probability of A and B is equal to the probability of A times the probability of B. So event A is choosing an ace. And so there are 13 aces. There are not 13, there are only 4 aces in a deck of 52 cards times the probability of choosing a black card. Well, half of our cards we know are black. So that is 26 out of 52. All right, and so when we multiply this in our calculators, you get 1 out of 26. And finally, number 12, cards are randomly drawn from a standard deck of 52 cards. Find the probability of drawing a 3 or a spade. So or is our key word here, so we need to use our or equation. But first, there are 2 equations for or, and we have to decide, is there an intersection between these 2 cards? Can I pull out a card and it be both a 3 and a spade at the same time? And we can. There is a 3 of spades. So I have to use this equation here, that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So event A would be drawing a 3, and there are 4 3s in a deck. plus a spade, probability of drawing a spade, and we know there are 13 spades in a deck, minus the combination, well, there's only one 3 of spades, so 1 out of 52. And then when we plug that into our calculators, we get 16 over 52, which does simplify to 4 over 13.